Hello, and welcome to this YouTube webinar on mining structured data and unstructured data together using Oracle Advanced Analytics. My name is Charlie Berger. I'm the Senior Director of Product Management for Oracle Data Mining and Advanced Analytics. And today I'm going to do this webinar and try to show you how we can mine both structured and unstructured data, something that a lot of other players have difficulty doing. They either do one or the other. And what we're going to show today is how we leverage the strengths of the database, including some really cool features of the database called Oracle Text, and then, of course, the Oracle Advanced Analytics option, and together how these combine and allow you to do some pretty cool things like mine structured data and unstructured data together. So at Oracle, we have a number of lawyers, and we're always required to show this safe harbor statement that says if I ever mention or imply anything that could be taken as maybe futures, to disregard that. This is only talking about released product here. So we'll continue on. So on the topic of sort of predictive analytics 101, I think everyone talks about this a lot these days. The idea is that there's data everywhere. It's huge growth of there's huge growths of data. Data is growing exponentially, and there's always this challenge of there's more data than there are data analysts who are able to deal with this data and mine it. And also, there's not enough good tools out there to deal with this. So this produces this sort of useful data gap, is what some people call it. Executives who feel they understand the impact of their data, the impact their data will have on their organizations, it's like 12%. So that means that about 88% of the data is just not, really felt that it's being used. And a lot of that data that they're complaining about is sometimes called dark data, sometimes called unstructured data, data that's not easily ingested and put to good use, put to work. So if you're going to be a vendor like Oracle and claim to have an advanced analytics platform to help with this type of problem, the data analysis platform ought to be extremely powerful and be able to handle large volumes of data. It ought to be pretty easy to learn, and it ought to be able to be quite automated, and most importantly, to support and enable deployment, because that's what it's all about. You want to take your predictive models that you've built, whether they include just structured data or structured and unstructured data, as we'll talk about further on today, and you want to deploy that throughout the enterprise, maybe within an application. So now it's a predictive application with recommendations or suggestions, perhaps based on the customer comments, Twitter feeds, emails, PowerPoints, PDFs, all the unstructured data that you never thought you could mine before. I want to show you how easy it is for you to add that to your analysis. So what we're going to be talking today is mostly about Oracle's advanced analytics offerings. We have offerings that add parallel implementations of machine learning algorithms that people use for clustering, classifications, anomaly detection, market basket analysis, and so on. These are parallel scalable data mining algorithms that are implemented in a database fashion. We also have, that's called Oracle Advanced Analytics. The components of that are sometimes known as Oracle Data Mining, that's the SQL API, Oracle R Enterprise, which is the integration with open source R, which maps to those same in-database SQL functions, and also the Oracle Data Miner GUI, which is what we're going to be showing and working with for most of today's session. There's also algorithms that we offer. There are also algorithms that we offer on the Hadoop platform, and that's called the Oracle R Advanced Analytics for Hadoop offering, and that's part of the big data connectors. So we offer these high performance parallelized implementations of algorithms both in the Oracle database and in the Hadoop platform, all on the premise of don't move the data. Data is big. Move the algorithms to where the data is. And so our offerings support data analysts, data scientists, and developers. We have drag and drop workflow GUIs. That's the Oracle Data Miner. You can also use RStudio, and through the integration with R, use your R scripts that get pushed down to SQL and point to the same data mining functions and statistical functions we have inside the database. By doing this, it extends the database, it extends the Hadoop platform into a powerful analytical platform. And what's really cool or important about that is that it really enables the enterprise to build and deploy predictive analytics applications. So really take all this data and take it beyond the data, the desktop of a data scientist, and deploy it throughout the organization. But we want to talk a little bit more about how we deal with unstructured data. So I want to give a little bit of the history and the evolution of the product to give a little bit of context for that. So this effort started way back in 1999 when Oracle acquired a company called Thinking Machines Corporation, and that company, which I came from, and a number of us who are still with Oracle today, all came from. We had a number of algorithms that ran outside of the database, but we said we're at Oracle, we need to figure out ways to re-implement these machine learning algorithms inside a database architecture. So something that would leverage the strengths of the database. So that's what the development organization did, and in doing so, we leveraged the strengths of the database. So counting, aggregations, parallelization within the database structure. And when it comes time to doing things like dealing with unstructured data, where there's a lot of capabilities in the database, namely a feature called Oracle Text, which deals with unstructured data. It can deal with what's called clobs and blobs, character large objects and binary large objects inside the database. And so we use Oracle Text to pre-process the data and feed it to the data mining algorithms so they can ingest that unstructured data in a fashion similar to how we ingest the structured data. So this whole evolution has been going on for some period of time, and now in 2016, coming out with release 12.2, it's a very, very high performant analytical database that can mine structured data, unstructured data, transactional data, geospatial data. It can do all those things inside the database. And our main value proposition is that the data remains in the data management platform. You can have all of your model building and all of your model scoring occur inside the database. It leverages your investment in the Oracle IT infrastructure, and most importantly of all, it allows you to deliver enterprise-wide applications. So for most customers, their customer reference stories are what used to take weeks, perhaps using competitive statistical or data mining analytical platforms that are requires you to move the data to a separate analytical platform. With the Oracle Advanced Analytics Platform, they can do it inside the Oracle database in minutes, seconds, at most maybe hours. So in total, what we have then is an architecture that just extends the database. We also have algorithms that run in Hadoop, the Oracle R Advanced Analytics for Hadoop offering. So today we're mostly going to be talking about the Advanced Analytics database option and how it is able to use Oracle Text and handle the unstructured data. So you have information producers, whether or not they're using R or what I'm going to show mostly today, the SQL developer extension called Oracle Data Miner, which then talks to SQL, the workflow then talks to the SQL functions inside the database, which can handle the structured and the unstructured data. And then once you've built the predictive models, the results, the models, they're all still, where are they? They're in the database. So the information consumers, whether they're OBIEE or Oracle Business Intelligence Cloud Service or any kind of application, any SQL literate application or tool can then talk to those results and talk to those models because they're just still inside the Oracle database. And that can be on the cloud or that can be on-premise. Oracle offers it, sort of all different flavors these days. So unstructured data. Unstructured data is growing at all the data is growing at a huge data growth, and you'll see many, many different studies on this, growing at 42.5% per year. On the unstructured data, 22% per year. Over here, I think those numbers are probably all underestimated what's really happening out there. But regardless of who you believe and what study you look at, the numbers are exploding, and the majority of that data is in fact unstructured data. And that comes in all sorts of different forms. So there's other studies that go off, and I've referenced these at the bottom. There's other studies that say 80% of this business relevant information originates in unstructured form, primarily text. So for most, and I guess I should say for many, if not most, data mining and predictive analytics tools and platforms, they're not really that good at dealing with unstructured data. It's sort of like they have a special tool that does just unstructured data, maybe just deals with maybe trying to solve sentiment analysis or do search, text search, those kind of things. Well, by moving the algorithms inside the Oracle database and leveraging all the other strengths of the database, namely things like Oracle Text, which has a large amount of search and text indexing and support for multiple languages and stemming and leafing and all of that, we just sit on top of that and we leverage the strengths of the database. So our in-database algorithms can ingest the structured, the unstructured data and keep right on going. And if you combine the structured and the unstructured data in general, your models should get better. The examples that I've seen show 15 or 20% model improvement if you can add in the relevant unstructured data. So what is this type of data, the unstructured data? Well, that's missing from most predictive models. It's your customer comments, like, hey, I just bought the product. Or if you go to a restaurant, they say, well, how was your dinner, sir? Usually you're going to say, well, the dinner's just fine. But you might go back onto OpenTable or Yelp and you might say, well, the waiter was pushy, my steak was undercooked, and the dessert was bland. So overcooked, pushy waiter, bland, all of those are words that I can use to mine if I'm going to try and build a more accurate, better predictive model, understanding my customers. Emails come back and forth between companies constantly. Why aren't we mining more and more emails? Customer service reps about this customer called and said his payment was late for the 5th time in the last 5 months. Any kind of PowerPoint, PDF, Word documents, these are physician and nurse abstracts. These are all the types of things that are fair game because they are managed inside the Oracle database. Oracle Text knows how to parse that out and give us a count of words, what we sometimes call a bag of words. So we're really talking about free-form written information that describes more about a situation. For example, a customer's interest in discount and sale and items than any kind of structured data could possibly communicate. So there's various different studies that I've referenced here that says, will your ability to manage unstructured content impact your ability to serve customers? In other words, will this unstructured data help? And in fact, yes, 85% of it, and you could say that in a very unstructured way, absolutely, you bet unstructured data can help. So that whole statement is really probably more rich in meaning. Absolutely, help, and so on. Those are just words that we can ingest in our data mining process. So let's continue on. So the way we do this, as I've alluded to a few different times, we use Oracle Text. It's a native capability of every Oracle database. So if you go to Oracle Text, or I go to Oracle database, you go to Oracle Text, or you go on the internet and you search for Oracle Text, you'll see how it uses standard SQL to index, search, and analyze text and documents that are stored in the Oracle database in files or on the web. So those files are typically stored as character large objects, clobs, or binary large objects, blobs. Oracle Text supports multiple languages. I think it's something like 25 or 30 languages. You can check it out on the internet or in the documentation. It uses advanced relevant ranking technology to improve search quality, but we use it to take, as you show in the example, as I show in the example below, to tokenize the unstructured data. So you see the unstructured data. Shopping at your store is a hassle. I rarely shop there and usually forget to bring your new loyalty card and hence never get the items at the sale price. Can a store manager look up my account online? There might be typos in there that, and what does that sentence even really mean? I don't know. Is that a positive or a negative sentence? Well, I'm not sure how to interpret that, but from a machine learning point of view, what we're really going to do is we're going to say, well, let's take all the words shopping, at your store, hassle. We're going to count each of these different words. We're going to throw out what we call stop words like and up and my and some of these different is, hassle, is a, all the stop words, the short sort of meaningless words, and Oracle Text comes with a stop words list that's just going to sort of white out those words, and it's going to feed us the more relevant words, at least what it thinks are more relevant words, and a count of those words. So if you say the word discount, for example, 5 times more often than the larger population in total says the word discount, that's going to be for us a coefficient on the word discount that's going to be 5x what everyone else is. So that's analogous to being 5 times taller, 5 times richer, 5 times more frequent visits, whatever it is, showing the relative strength of that token or that word compared to the rest of the population, and that has meaning. So we're going to use that. So all of our algorithms, and you see the list of the algorithms here that are in database data mining algorithms that are accessible via the native SQL functions, native access via the R integration, and also accessible via the Oracle Data Miner GUI. All of these algorithms can, because they're in database implementations, they can analyze structured data, of course, but they can also ingest unstructured data. So I'm doing this webinar because sometimes this point is somewhat lost on people. And down here, you just see this little sort of footnote at the bottom that says text mining. Oh, by the way, all of these algorithms, if you have clustering algorithms or decision trees even, or support vector machines, all of these algorithms can mine, of course, structured data, but they can also mine unstructured data and, in fact, transactional data, like market basket analysis data. And I'm going I'm going to show a little bit of that, but most of the focus is going to be on the unstructured data today. So we can do all that very easily because of our in-database implementations, leveraging all the strengths of the database. And we're going to show you how we can really think of this. You can think of Oracle Advanced Analytics as really extending traditional SQL that says, select all customers where I aggregate their purchases of shoes is greater than this. Well, I can add that and where I predict they will buy more shoes, or where they will likely churn or likely voluntarily leave the corporation or associate market basket analysis. These are all just very powerful SQL verbs that if you go to the SQL reference documentation, you'll see the data mining analytical SQL functions as well added to that. So that's what we're really talking about. We've extended the language of SQL to add in very powerful analytical SQL verbs, sort of machine learning verbs, if you will. And so here's a graphical. I'll go to the live thing, but this sort of communicates what we're talking about today. We're taking, first of all, transactional data. This is, in a sense, unstructured data too, right? It's semi-structured. It's data that comes in. How many purchases did you make of beer, of diapers, of soda, of butter and milk, and so on? I'm going to aggregate those all up to say the average amount of beer, diapers, soda, milk, or whatever. And I'm going to bring that in as a nested table, if you will, that says for each customer, what were the items they purchased, and I can either take the max or the min or the median or whatever. Here, I'll probably take the sum, right? I'll probably take the sum there, which is what I do. Over here, I have unstructured data. Now, I'm calling this out separately. You don't have to do this. This is sort of the old way of doing it, but I call it out separately just to highlight what's going on here. We're going to take the unstructured data, the customer demographics and comments. We're going to develop a text index here. So we're going to tokenize that data and give a what's called a term frequency inverse document frequency coefficient for each term relative to the larger larger population. Here, just because it's cool and interesting, I'm nesting in a predictive model. So I might buy a FICO score from someone else, but I might say, well, I have enough data here. On my way through this analysis, I will make my own prediction of what the person's credit score rating is. By the time I get to here, I've joined together this semi-structured data that I've totaled all up to sums of purchases. I've added in this other customer data where I've added another prediction on the fly. I've taken this additional customer demographic data, including all of the free text, free form customer comments like the one I showed before. I do an index of that. I join them all together. So by the time I get to this 360-degree view of the customer, I've got a very complex nested table of a row for each customer. But when I get to things like comments or purchases, it's a nested table that shows me the tokenized words and their coefficients, or the purchases and the amounts of those purchases. So when I then go to build my models, because they're the in-database implementations of these machine learning algorithms, I can apply many different models to the data, support vector machines, naive Bayes, decision trees, clustering, whatever I want to do. But I'm going to consider the demographics, the past purchases, the comments, tweets, anything they have in here, because they've been taught how to know about structured data, unstructured data, transactional data, and if I add a geospatial data. At the end of it, I'm going to have my scored list of customers, the most likely customers to respond. I think in this case, we're trying to predict who's going to buy an affinity card, who's going to hyper respond to an affinity card, something like that. And I can also generate the SQL scripts, or I can just automate this through the workflow API. So it's just like you'd see from any other statistical or data mining vendor with a workflow type of approach. But what I want to point out is this ability to mine the unstructured data, and in fact the semi-structured data up here as well. That's a little bit different from what you'll see from other players. And of course, or interestingly, this all runs exactly the same, whether or not you're running it on-premise or up in the cloud, in the Oracle Cloud. In either case, your database is intelligent enough to mine structured and unstructured data, and it's the same code regardless of where you have it. And getting even a little bit better here, I think, we have something called Big Data SQL. Now, Big Data SQL extends the reach of SQL down to the Hadoop platform. So a lot of times people may keep their tweets or their customer comments or documents or who knows what in JSON data types. It might be Hive data, it might be social media data, a bunch of different types of data over here that I want to query, filter, aggregate, and join that data, maybe just all tweets that have anything to, all tweets that have some relevance to shoes or hamburgers or this particular restaurant or whatever. I can go filter that. I can join that data to the other data over here, and then any kind of data scientist can use the SQL client, the Oracle Data Miner GUI, or the R client to access and data mine that data. And if you believe all of this, that better data and more data of the right type is a good thing, then you would say that, well, if I had a model with 20 variables, I could probably build a pretty good model. But if I figured out the right variables, because I've got the right customer comments, the right emails, the right PowerPoints, the right purchases, a model with more variables, I should get a better model. If I add even more variables, I should get a better model. And if I look at the land of big data with spatial location data, web visits, sensor data, unstructured data of any kind, text, comments, physician's notes, nursing notes, whatever, customer service, repairman notes, whatever, all of those things, theoretically, if it's the right kind of data, should give me even better models. And if I think about deriving new variables out of that data in an intelligent fashion, like what's the ratio of the amount of dropped calls you've had per month recently versus in the past, or if I look at your checks written in the past versus today, all these kind of derived or engineered features, I can think about the data in the database, use my domain knowledge to build even smarter and better variables, or what we call engineered features, and theoretically build even better models. So that's what it's all about. It's leveraging the strengths of your data management platform, including all this unstructured data, to build better models. So I'm going to now delve into a quick demo. I'm going to do that using the Oracle Data Miner graphical user interface, this workflow sort of GUI here. It is part of the SQL Developer offering. It's something that people download from OTN always. There's millions of these that get downloaded every year, and the Oracle Data Miner is just an extension to that. So at this point, I'm going to show how I can use this one-click data mining here, where I just simply say, well, I have some data, and I have some text data like customer comments here. It's a CLOB data type. I'm just going to set it to text, and off it goes. And I'll show you how that works out in the detail. The problem statement that the business use case that we're going to try and walk through here is the idea of trying to figure out who is going to be a likely best loyalty card responder and what are their profiles. So I have these loyalty cards. Maybe I've set up a scenario where I've randomly given them out to 5% of my population, and then gives away maybe a 10% discount. Now, I don't want to give those cards away to 100% of my population, because if I do, my revenues will go down by 10%, right? 10% discount, 100% of the population, it's not a good thing. So maybe it's like a frequent flyer, special loyalty card kind of thing that I want to hand out judiciously just to people who I believe that if I hand them this card, they'll spend 11% or more. They'll use it to buy gifts for their friends and family. They'll do bulk purchases for their neighbors. They'll really sort of go to town on this thing. So I want to also, I want to do this experiment, build a model. I've done some experimentation. I've got some data that I want to analyze. And in that data, I have these customer comments that I've gathered, like shopping at your store is a hassle. I rarely shop there and always forget to bring my loyalty card, the one that we were talking about before. So can I use that data? Well, we can. So we're going to show you how we do that. These are sort of the summary slides I'm going to come back to. So let's go back over here. Here's the demo. First of all, I want to point out that we are just simply in SQL Developer. So this is SQL Developer 4.1.3, and I am using the Oracle Data Mining extension right here. So that's a separate configuration. Once you download and install SQL Developer, you just go through here and you say, I want to view Oracle Data Miner. There's some connections, some configurations on how to do that. It'll take you 5 minutes to set it up, and you're off and running. So what I have here is a scenario that I've already done, but I'm going to go up here and start with a blank sheet of part of my workflow here. So I'm going to go get a data source. I'm going to use this data that we ship sometimes with the database, and it has some data that's relevant to text mining kind of situations. I'm going to use this data mining data text build. Okay, so it's got some data that has customer comments, and I can see a little bit what the variables are. I can move them all over or not. There they all are, and there's my data. So I just want to show what some of this data looks like. So I'm going to view the data, and as you can see here, I see this affinity card is great. I think it's a hassle to remember it all the time. I purchased a new computer recently. Can you ship the manuals to me? And so all of these are customer comments in here. And what I want to do is show how easy it is to just take this data and mine it, but I don't have to exclude that data. I can just keep right on going. So I'm going to go straight to I'll show some more complicated versions of this in a minute. I want to show the basic one first. I'm going to build a classification model. I'm going to connect that to that. So when I do this, it's going to say, what's my target field? It's going to be this affinity card or this loyalty card. My customer ID is going to be customer ID. Now I have these input attributes or input variables, and I have this automatic handling of how to treat each of these variables as text or unstructured, numerical data, categorical data, and so on. I'm going to change this. So I've turned it off, and I'm going to override. So now I'm going to say, well, this is not a categorical data. Don't treat those as long text strings. Instead, treat them as text. That's it. That's all I have to do. So under the hood, a lot of things are going to happen, and I want to show you this. Under the hood, I'm going to tokenize all that data. I can also do themes. I'm going to pick which language. I'm going to default to English here, but I could have multiple languages here if I wanted to. So I'm going to stick back with the English. I can support stemming. I have stop words, okay, that are going to be removed automatically. I can add in my own stop list here and step through for different customizations of this if I want to go and put in my own thesaurus for like a medical literature situation or my own terminology at an automotive use case or whatever. I can replace the thesaurus that comes with the Oracle text with my own, and I can extend it. That's not supported via the GUI, but I can read the Oracle text manual and go under the hood and change those kind of things. And now notice also when I go to mine this, I'm going to set this up here so I can just kind of talk this as I go to run this. I'm going to go run this right now. And so it saves the workflow and it starts the launching of the models here. But what it's going to do is it's going to perform the performance matrix. It's going to do the ROC curve. It's going to do a lift and profit curve. It's also going to automatically sample randomly a 60% sample of the input data set. And then it's going to have a holdout sample of the other 40% that it's going to use for testing purposes. And once it does all that, which it just finished in a little bit, it's going to have built a generalized linear model, a support vector machine with default settings, automatic settings for whether it's a linear or a Gaussian model. It's going to do a decision tree, which can also handle unstructured data and a naive Bayes. So I'm done. If I go through here and look at any of my models, let's say like a support vector machine model, I can see that I have for the target field 1, if I just sort this, then I see the top most relevant variables here. If I say, well, I just want to see the comments, so if I sort just based on comments now and say sort this, then I find that shops, Texas, other, these are all more and customer, or sort of the other direction, but these are all variables that either in a positive or negative direction affect or influence the target outcome of 1. Yes, they do hyper respond to this loyalty card. So that's all it really is. I'm mining the data in that fashion. If I have another variable, let's say a generalized linear model, it shows how that works here in its ingestion of that. And if I go through the same thing here, it's a different model. So you can see how that sort of takes the coefficients for the comments here as well. So it's very powerful and it's very easy. So that's kind of the way it works. I've gone and created one already over here. So I have my different models. I'm going to compare my test results over here. So I get different metrics for predictive confidence, average accuracy, and so on, and different lift charts so I can see which model does the best job. And it looks like the support vector machine in general does a pretty good job. Okay, so that's quite interesting. And I've done a whole flow here, which I can now take another set of data, the text apply data, and make my predictions. So at this point, it's saying make a prediction probability. Also give me the reasons why. I've also added in some additional variables to be carried forward. just for the purposes of showing some results here, make it a little bit more interesting. And so now here are my predictions, which I can sort the prediction probability in descending order. And here they all are now as the most likely to hyper respond to the offer. And here is the prediction details. So it looks like these people are saying something about others and shops and never, and these are helping to influence my prediction that this person is in fact going to hyper respond. It's a 40-year-old person, and so on. So that's how I can very easily data mine my structured data, my unstructured data, and so on. Now I also have another scenario here, which is a scenario where I have some sales data, customer data. It's the one I was showing before. I just want to show a little bit more busy scenario here, where now I can view my models. And again, I have the support vector machine here. I'm going to just search for the comments, COMMENTS, and again search through this, and I see the comments of forget and sending and store. These are all sort of positive or negative influencers on my outcome. And notice I can have a lot of comments. Okay, and each of these are pieces of data that I don't necessarily want to throw away. And as I said before, my experience working with customers and noticing what they get for results, 10, 15, 20% perhaps model improvements when you do this. You can also do this in unstructured data, in clustering situations. So here's some clustering. It's the same data, but now we're going to do some clustering. So I just want to show how this works. We're using the k-means clustering. We could use a expectation maximization or a orthogonal partitioning clustering. And here, in each of these cluster nodes, here's a 4%, 8% of the population, and these are the variables that help distinguish what that cluster is. So they say the word idea and remember and shop, but they're also from California and they're mostly divorced. But some of these words are appearing in their communications in their unstructured data, and that's helping me to separate out and identify the different clusters, the different segments. So maybe they talk more about a certain political candidate, maybe they talk more about organic foods, whatever it is. So we don't want to leave all that sort of dark data or unstructured data unused. We want to tap into that, and with Oracle Advanced Analytics, that's quite easily achieved. So that's most of what I wanted to show. I just wanted to kind of recap some of this through a few more PowerPoints. So here we're doing the loyalty card, identifying the best loyalty card responders and their profiles. We're using this sort of 360-degree view of customers, which includes the unstructured data. So our rules now, if it's a decision tree, include the relevance, I guess, of each of these different terms in the customer's profile relative to how often these terms appear in the larger population. So kind of complicated concept, but basically it's a decision tree that can now include the unstructured data as well. And the same thing applies for the clustering and the other types of predictive anomaly detection and so on that we would do. The coefficients, as I've shown before, say in the support vector machines, are just going to show as positive, or the red as negative influencers on the outcome. It's the same as using structured data. It's just a slightly different representation, but it's very easily achieved because you just change that setting to text, and everything else happens automatically under the hood. Here's the clustering example, as I showed before. So now we have a hierarchical cluster, and again, the clusters are defined using structured data like household size, but also the relevant prevalence of these terms relative to the larger population. So this person says discount a lot, they say shop and a lot, and they forget. So this is a certain category of people. So maybe you want to say, hey, reminder, don't forget to use your discount card. Come in on Saturday for your big sale that we're having, something like that. And again, the clustering viewers, they're the same. They just handle the structured data, the unstructured data all together. So it's very sort of straightforward and easy. So now, sort of wrapping up, if you want to try this out, it's very easy to get started. There's a number of different ways to get going. There are, if you send me an email at charlie.berger@oracle.com, I'll send you this list of links. There are also, I'll post these this PowerPoint along with the YouTube video so you can get access to that. What I like are these tutorial series, and if you go click on that, it'll take you off to these tutorials, which are a number of them here. So setting up Oracle Data Miner, using the GUI, star schema, which is one of the ones we were just doing, and the other one that I was going to point out was this specific text mining one. So here's the text mining one. If I click begin tutorial, then it takes me off to this whole sort of thing that'll take you about 30 minutes. And if you step through this, it'll take you through how to set it up. There's your data source. So I scroll on down here, it'll tell you how to change that to text, just like what we did before. And you'll scroll through the whole methodology. There's your customer comments included in a cluster and so on. So it walks you through that whole process. A very simple and easy way to get started. So that's what I like quite a bit. There are also some other things that are kind of interesting. There's the 2-day course. We also have a great partner, Vlamis, who actually hosts all this up on an Oracle Cloud, and they provide that free to their to the community. And you can go there. There's Dan Vlamis, and they host it all up on the cloud, and you just go up there and fill out a form, and they'll let you take it for a test drive for a few days. They also provide consulting in their official Oracle University course instructors, so you can also tap into them for that if you like. But it's a very simple, easy way to just give it a try and take it for a test spin. From time to time, we have, I guess it's once a year, we have a user group meeting. We had our last one at Oracle headquarters at the end of January, and I wanted you to mark your calendars and please join us for the next one that's coming up at the end of January 2017. And there, hopefully, we can have you come in and perhaps even deliver a presentation on how you are using Oracle Advanced Analytics to mine your structured and your unstructured data. This forum doesn't really allow me to take any questions, but if you do have any questions or you want to follow up, you can send me an email at charlie.berger@oracle.com. I thank you very much for your time, and thank you for watching this YouTube video. Thank you.